There we go. Okay, so hopefully everyone can see this. So what we're going to do is we're going to have a look at how to import a data set and some other data sets around it. So some of you may have come across this already. So the US government has some of their data sets available online, and one of them is called the Chicago crime data sets. If you Google that, just search for Chicago crime data set, you'll find that. And what is quite nice about it is that it gives us a way to easily download that, and then we sort of get a list of all the crimes that have happened from 2001 until the point at which you download it. We get it in a CSV file, and you can kind of see roughly in the background what the different columns are. So we actually have got it in the CSV format. That seems to be the easiest one to work with. And roughly, I guess what you're always trying to do when you're working with a data set is we're going to take it, we're going to put it into Neo4j, and then hopefully we're going to come up with some amazing queries and make money. I don't really know how to make money from this one, but maybe you have some ideas. So the first thing that you want to do when you get a data set is well, let's have a look at it. What have we actually got? There's a lot of tools that you could use to do that. So obviously, if you're familiar with the Linux or Unix operating system, you could grep through the file, or you could use tools similar to that. You could search them. I quite like these days to actually go and explore the file using the Load CSV command in Neo4j's query language. I'm going to quickly show you how you'd go about doing that. So I've got this is my project which has all of the different stuff for this webinar in. So first of all, we've got to get Neo4j started. So I can just start it up here. So we'll just start that up and give it a few seconds, and then I'm going to do a little bit of exploration of what is actually in this data set. So you can kind of see here, it gives us a little message that says, hey, I'm ready. This is where it is. Let's have a quick look. So we've got nothing in there at the moment. So this is like a fresh download of Neo4j with nothing in, and we can, if we go and grab that little query, we can have a look what is actually in there. So we do quick query. So in case you haven't seen the syntax before, there's a command in Cypher. So this is Neo4j's query language, and you basically, I guess it's reasonably readable. So you're saying I want to load a CSV, and the first line's a header, so that's what the with headers is for, and then you can give it either a HTTP URI, or you can point it at a file with the file prefix. So in this case, it's just a file on my laptop somewhere, but you can obviously put whatever you want in there. And then we're saying I want to treat each row of the file. I want to look at each row of the file, and I'm going to refer to it as row. That name doesn't have to be row. You can call it whatever you want. And then I'm returning it, and I'm saying actually I just want to see one of them. So I just want to get a brief overview of what is actually there. And then you get back, so you can kind of see we get one row back, and you can kind of see roughly what's there. So we've got an ID, we've got a location, got some coordinates, got a description, got an FBI code down here. That might be interesting. We've got a type of the crime. We've got a description of where it was, and you can kind of see there's some other data. And we could obviously, if we wanted to if there were some missing values in there, we could up that to 10 and have a quick browse and see, oh, what have they actually got in here. So that gives us a brief look at it. So that tends to be my starting point. So I'd suggest that's quite a nice way of getting an overview of the data set. And if we take that back into here, so that's one record that we've just looked at. And we might then go and say, okay, what are some interesting fields that we might be able to put into a model to do some exploration on this data set. So I've picked out a few. So maybe the year is interesting, perhaps the primary type of the crime is interesting. Could be the description of where it is, the location description, which beat did it happen on, is there anything like our crimes happening on a particular beat. And we might also be looking, are there any values in here that we know that we can connect to another data set. So actually, retrospectively, I realized that the FBI code was quite an interesting one, and we'll get to that later on. So the next thing after that, so we kind of looked and seen, okay, this is what our data set looks like. Sketch out a rough initial model. One thing to keep in mind here is it doesn't have to be perfect the first time. It just has to be something to get you started. So this is a you don't have to. I've drawn this in a tool called Arrows, which you can probably send a link to later on. but you could just draw it on a piece of paper, or you could just have it in your head if you prefer. So just to quickly go through it, so the crime is like the center of our world. So we're going to put all the crime and its data here, and we're going to say, okay, it's committed in a location. The type of the crime is the crime type. We're going to say it's in a year, and it's on a particular beat. So that's how we might start. It's a quick overview of Cypher syntax. So obviously you've seen load CSV and you've seen the return command, which load a CSV and then return it. Other commands we're going to look at in this session are match. So match is a way of finding a pattern in a graph, and then you probably then go on to return it, or you can do other operations on it. Create is used to create new things in the graph. So you could use it to create a node. You could use it to create a relationship. You could use it to create multiple combinations of those. And then the one that my favorite command is the merge command, and that's kind of a combination of the two. So if you merge on something, if it exists, then it just returns it, and if it doesn't exist, then you create it. So it's kind of like the upsert in SQL. So what I typically did, what I did with this data set was I kind of started off with, so this is what I call this the naive version of load CSV. So this is the simplest way you might start. So we're just looking at creating one relationship and a couple of nodes. So if we go through it, so we're saying I want to merge a crime, so I want to ensure a crime exists. So create me this is just an identifier, this crime here. This is a label, so these are used to identify the nodes. So we're saying I want to create a node which has a label crime, and then these are some key value pairs, some properties that we're going to put on this. We're going to put the ID, that's the ID of the crime, that's how we're going to identify it. We're going to put description, case number, and so on, and then we're going to create another node to represent the crime type. And then we'll merge it there, so we're going to ensure that there's definitely a crime and connect it to a crime type. So that's fine. That will probably take quite a long time if you were to run that as your opening gambit, given that there are, I think there's about 4.1 million rows. So what I've typically found when working with users and customers of Neo4j is that it's much better to start off with something a bit smaller. So start with a sample of your data, and sort of figure out, does this actually work? Is the way that I've designed the model actually helping me? And so what I'll typically do is start with a sample of the data. So you can kind of see here, I actually got a new command. So we've got a with. The with command allows you to sort of connect two parts of a query together. All it's doing in this case is saying I want to load from rows from this file, but I want you to stop at 100, and then I want you to create the graph with those 100. And obviously this is much quicker than doing it with 4 million. Second tip would be that merge. So typically when you're merging, there's a key of some sort, often a primary key, perhaps in the domain, which indicates, hey, this thing is unique in this way, and you probably don't actually need all of these fields to describe uniqueness, because the fact that a crime is a particular ID is more than enough, and these are just additional bits of metadata that you can add on. And so by doing this, we allow the Cypher compiler to go and say, okay, well, cool, I can look up that ID because you would probably have indexed it. We'll have a look at how to do that as well. And so then it simplifies its job. So all we're saying is I want to make sure that there's a crime with this ID exists. If you're creating it for the first time, so hence the on create, I want you to set these properties up. There's also another equivalent called onMatch, where you could set, for example, an access counter. Say how many times was somebody actually accessing this crime. I could update a property like that. And then we didn't have to change anything for our primary type, so that stays exactly the same. So we just merge that, and then we can connect them together. So the only change here is just we're just kind of splitting these things up. So always merge on a key. As I mentioned, you want to create some indexes on your key. So Neo4j lets you store indexes, and as you can see from the syntax, they're stored on label property pairs. So nodes can have labels, and then you can say, well, for nodes with this label, I want to index this property. So that's what the syntax looks like, and then in our graph so far, this is how we might index it. So we might go, hey, I want to create an index on nodes of crime label and the ID field, but for crime type, I want to do name. Thing to keep in mind, Neo4j only uses these indexes to find the nodes to start your query from. So they're not used in a way that they are in a relational database where you're actually using them to kind of go and do scans of records. They're only used to find your starting points, and then after that, everything is being done through using effectively Neo4j's pointers. Another thing, another tip. So we are actually going to run all this, but we're going to going through some of the tips first. Is try like for optimal performance, you want to keep to one merge per query. So in our first example, we were kind of merging lots of different things, and the temptation is, oh, I can just do everything in one query. But that makes it very difficult for the compiler to actually optimize what you're doing. So what I've sort of found is that the optimal way, once you've kind of gone beyond, I guess, beyond the sampling, is actually keep it to one merge per query. So here we'd go, okay, I'm going to run one query which does my crimes. I can then do another one which does my crime types, and then I can do another one which connects them together. And this you'll get the quickest performance if you stick to that rule, is what I found. Another interesting thing is that if you know that in your CSV file there's a lot of duplicates or duplicate records. So for example, the crime types, there's only about 30 of them, and we've got 4 million records. There's going to be a lot of duplicates, and so merging on the same thing over and over again, there's not really much point doing that. So what is a better approach is to actually filter them out. So there's a distinct keyword in Cypher, and you can say, actually, I want to only pass through the distinct ones to the merge query, and then that's another way of also speeding things up, because you're basically saving yourself from running unnecessary operations. Another thing to keep in mind is that the load CSV command can be attached with using periodic commit, which allows you to, I guess, kind of as the name says, it periodically will flush by default on 1,000 rows. So every 1,000 rows, it will then go, hey, I'm going to persist that, and then I'm going to go on to the next 1,000. So in this example here, we're saying, actually, I want to use a periodic commit on my merging of crimes. So every 1,000 crimes, it's going to persist it to the log. If you don't use the periodic commit, it will wait for every single thing in the whole transaction to happen, and then persist it all together. Which is usually fine, but when you're doing these sort of imports of a lot of things, Neo4j keeps all of its transaction state in memory, so you need to be relying on having quite a lot of RAM available on your machine if you want to do that. So just some other things. I think I've kind of covered some of these already. So yeah, it keeps transaction state in memory, and yeah, you can. I mean, so it does start with 1,000 rows, but you can configure it. So if you decide, hey, I can actually handle 10,000, then feel free to change that. Just put 10,000 afterwards. It's at the moment, as the last line says, it only works with the load CSV command. Another thing that I found is useful is actually build up these commands into a script. So the way that you can do it is if we go to let's go to the browser now. So I've got a script in here. So it's down here. Hopefully that make that a bit bigger, then you can see it. So what I tend to do is I'll build them up in the browser. So if you've not used the browser before, there's a :history command, and you can kind of see what have I been doing. And what I'll typically do is kind of go and copy those commands and put them in a file, so that I can refer to them later on, and so I don't forget what have I actually been doing and what was working and what wasn't. And so you can kind of see here, this is kind of my script of what I want to import. So I've got some indexes at the top, so I know I'm going to do some stuff with these nodes, so I want to make sure they have an index on so that the import's quick. So you can kind of see that's the first bit. You can put comments in the file as well. They're just to help you. They don't get executed. So we're merging some crimes here. I can kind of get away with this because there's only a few. We've got some crime types. We've got some beats. We've got location. Then we're connecting the crimes and the locations. We've got the crimes and the beats. You can kind of see it all the time. It's the same file. We're just doing slightly different operations on it, and always following the idea of create the nodes first, and then create the relationships afterwards. That's it. So what we can do then is we can actually choose to run this. If I quickly, so you can see what does that look like. So there's there's a tool that comes shipped with Neo4j. So this is the syntax for running it from a Mac or from a Unix command line, but it also comes with the Windows version as well. The command is Neo4j shell without the space, and then you could pass the file in. So all we're doing is we're saying I want to run this script, and the file that I want you to use is called, in that case it's import. We'll actually give it a try with samples. If we go Neo4j, so we'll point at our Neo4j that we started. We'll just go Neo4j shell, point at the file, so the file sits in here. So we've got our sample, and then it will run through. So you can kind of see it did the indexes first. Now it'll go on to some of the other things. So I guess the next thing after that would have been the crimes. So we create all our crimes. One thing I haven't done, which you could do, if you've got a lot of things and it takes a bit longer, is you could add in a message that said, hey, currently doing crime types. So you can make a little query that just returns a bit of text so that you would see that on here and know where is it actually up to. Okay, so that's now finished. So what we can do is if we go back to our browser, we can refresh that and have a look. And so now you can kind of see on this left-hand side. So this is sort of your schema overview. So we can kind of see we've got some crimes in there, and if we click them, we can get it. So I'll just minimize this for a bit. So this is, as I said, this is our schema overview. We can see what labels have been put onto nodes. We can see what relationship types we've got in our graph, and we can have a look at the property keys that are there as well. You can click on any of these, and it will run a query to give you like a sample of what is actually there. So what I've done, I've got 25 crimes, and you can use this button here. So this is the full screen button. And you can have a quick look. So you can kind of see along the bottom row. So if I click on it, it will hold the text there for me. So I can have a look. Well, what have we got here? So we've got a specific ID. We've got a description of the crime. We've got a case number. We've got, did they get arrested? Okay, they did in this case. And then it connects here, so you can kind of see the relationship type there. So what was the type? Criminal trespass. What beat did it happen on? 222. Where was the crime being committed? And up here you've got this is the key of what do the colors mean. So blue is the crime, green crime type, and so on. You can obviously scroll this around. You can open up other ones, and they're going to be connected by the crime type or by the location in this case. Those are the things that the crimes are connected by. So that's how I typically would find myself starting out, and then we've got another couple of example queries in here. So we could have a look. Well, how many crimes are being committed in a restaurant? I'll just move that out of the way again. So we could run. So this is quite a simple query saying, show me how many crimes of the ones I've imported were in restaurants. So we're just saying, I want to match any node that is a location, but it has to have this ID. So this is the restaurant ID, and find me, go and follow out the committed in relationship and find crimes on the other side. We don't necessarily need to have that. We could get rid of that. We get back how many there were. And then we've got another couple down here. So we could also run this and say, hey, get me a particular crime. I wonder if this one's actually there. It should be. Yeah, so there's the crime. We could open that up and have a look. Another thing to keep in mind, when you're doing your import, is that you can have a quick look and see, hey, have I got my index is actually there, and so you can see what has actually been created. So what this tells you is, hey, yeah, there are some indexes. There's one on crime label ID property. It's online. We'll have a look later on. What does online actually mean? There's another state that you'll see as well, but for now, because there were very few nodes, or actually no, because we created the index first, it's straight away online. And the way the indexes in Neo4j work is that when they get created, they go and index any nodes that are already there that match the label property, and then any future nodes that come in, those will also be indexed. All right, let's go back to the slides again. So hopefully in that very brief demo of Load CSV, you can kind of see it's a bit of an ETL power tool. You can pretty much, if you've got a CSV file, it's quite a nice way. You can sort of do the whole flow from, hey, I've got the raw data, I want to have a look at it, what have I actually got, to playing around with the sample, and then you could go up. So we did just 10,000 nodes, but what we've seen is you can probably go up. Probably 10 million would be the maximum, and probably between 1 and 10 you might start to get a bit frustrated about how long it's taking. But for the smaller data sets, particularly when you're prototyping, this is a really quick way of getting up and running. But that leads us nicely into, well, what do I do when I've got to the point where, hey, this is starting to take quite a while? And the reason that it takes quite a while is because everything that you're doing is being treated, is being run through Neo4j's transaction engine, and so everything is being persisted to a transaction log so that it can be recovered if anything crashes, and then it's being flushed down to the store files. Now, what we have, if you're doing a bulk initial import, so it could be from a relational database. Perhaps you're taking some data from a relational database and you want to put it into the graph to answer some particular questions, or it could be a dump from Hadoop. So actually either of those is probably quite similar to what we've got in our crime datasets. We've just got a big CSV file which is very long and very wide, and there's just lots of different bits of data. So you could imagine that could easily be a SQL query dump where they've just joined all the tables together and gone, hey, there you go, there's your denormalized dataset. So for those types of data, when you're doing your initial dataset and you're sort of dealing with much bigger data sets, what you can use is the Neo4j import tool, which comes with Neo4j when you download it. What this does is it skips over the transactional layer of Neo4j and just writes straight to the store file directly. So you skip the transaction layer, so that's your trade-off. So if anything fails in the middle, you've got to run it again, but it's much quicker. So one of the things you've got to keep in mind when using this is it expects to get files in a particular format. So effectively, it's optimized for it to be able to read them and then get them into the store files as quick as it can. So this slide is showing what does that format actually look like. So along the top row, we've got the node format, and they all follow the same style. So you've got an ID. So that's saying, well, what is the identifier that you want to use to identify this node? So in our case, that's going to be the key that we were merging on before. There's then a column where you can put :label, and in there you can put a comma-separated list of labels. I think in our case we've only actually got one for each node, so we'll see that. And then description is an example of another field that we might want to put in. So you can put as many as you want. And then we've got the same for the beat. And then relationships have this format that you can see here. So we've got start ID, so that's a keyword, and then you're saying what is the, so we call this an ID group. So this crime here refers to the crime here. So each of the files ends up with, I guess, an ID group, or I suppose it's like a grouping of the label IDs. And so when we're saying here, hey, my start ID is this, and by the way, it's of type crime, so I want you to go and look in this file. And then we've got an end, which is beat, and then we'll be able to connect these files together. Type is the relationship type. You can also pass that in as a command line parameter, but I think in this example we're gonna just have it in the file, just so you can see how that works. So obviously, while this is running, there's sort of a map of these values of the keys that we're using in the node files to sort of Neo4j's on disk IDs. So that's how it's actually able to connect the bits of data together, and it's quite an optimized sort of map solution. So let's just quickly, so how are we going to we've got this big CSV file, it's got lots of rows, lots of columns, we need to get to those sort of more specific CSV files. So what I've actually got is we need to come up with some sort of translation phase. We've got to get from this big CSV file to our smaller ones. So I'm not going to show how exactly this. I'm not going to actually run this as part of this webinar, but I use the Spark framework to do this. I guess if you want to read about Spark, there's lots of information about that, but I was just using it to process the CSV file because it has a very nice abstraction for taking a CSV file and in parallel running lots of operations on it and spitting out some new ones. So I've got a Spark job, which I'll have a quick look at, which takes in the Chicago crime CSV file and spits out lots of Neo4j files ready to be imported into the database. So for the curious, this is what it looks like. So we're basically saying, so it basically has a main method where we just say, hey, I've got a file. You have to. So we're defining it as an environment property, which is the path of the file, and then we're going through and we're basically just generating the files for each of the types of nodes and then relationships that we want to create. And all we're doing is we're just saying, hey, which column do each of the bits of data reside in? So here you can see crime type is in column 5, whereas beat is in column 10. And then what we've got, this is the label that we talked about before. So we're just saying, hey, I'm going to have a label field, and this is the label that I want to create. This is what the generate file command looks like. We're kind of just going over the CSV file and generating a new entry for our Neo4j specific CSV file. This is how you would run it. All this code, by the way, is on a GitHub account, which is linked to on the last slide of the presentation. So when Greta sends that out, you can obviously have a look and play around with that if you want. It's reasonably simple to run. I'm just saying, hey, I want to run this job to generate my CSV files. Here's how much memory I'm going to give it. So I just say 5 gig, just random amount of memory. That seems to work pretty well. And a minute and a half later, you've got your CSV files ready to go. Okay, so now we're at the point where we want to ingest those into Neo4j. So this, I'm going to quickly show you what do these files actually look like. So I've put them into a folder called temp. So if I do, let's have a quick look. So these are the files that we're going to be working with. So you'll recognize some of the terminology by now. So we've got the beats, we've got the crimes, we've got the crime. Then these are the relationships between things. So if we can just have a quick look at those. So let's have a look. So we've got temp crimes.csv. So this is what it looks like. So this is just sort of an extended version of what was on the slide. So we've got our header saying, hey, this is my ID column, this is my label, it's crime. I've got a date, and I've got a description. I've got a case number, an arrest. Let's have a look at another one. So crimes. Let's have a look at the beats that the crimes are happening on. Actually, it would probably be better to look at the beats first, then we can connect them together. So let's have a look at the beats. So these are the beats. So we're saying, hey, these are the beats that I've got. So I've got 1, 1, 3, 5. These are just IDs all the way down. And then this is the file that creates the relationship. So what we did with merge, we're now doing with these files. And then there's going to be we're going to feed it into Neo4j, and it's going to process it for us and create us a graph. So what we're doing here is saying, hey, this crime ID, connect it to this beat ID, and this is the relationship type that you should use. Okay, so if we go back here again, so we've got those files. I also did a bit of a cleanup step to get rid of any rows which had null values in some of the ID columns. There were a couple of those, and wasn't quite sure what happened, but it seemed better to import a clean data set. So I did just have a command that gets rid of nulls. And this is what the syntax looks like for importing it into, importing into Neo4j. The way that this works is that we create a directory that is a Neo4j database, and then we need to point our Neo4j server that we've been running before at that and start it up. So this is the script. We're going to run it in a second. But all we do is we say, hey, where's the data residing? So we've got data equals temp. Where's the Neo4j that you want to use? Or where's the Neo4j import command? So cool. Okay, it's in this folder. And then we're going to go run the Neo4j import. So we'll have a quick look at what that is. So that's a command line tool that comes when you download Neo4j. It's again the Windows version is Neo4j import without the hyphen. And then we're going to say, okay, where do I want to create it? So we're going to put it in a folder called, well, it's going to be temp crimesdb. And then we just need to tell it, well, what do you actually want to import? So I want to do some nodes, the crimes, and then you say, okay, I want some beats, primary types, locations, relationships with these ones, and then you run it. So what I've actually done is I've got it in a file. So if we have a quick look, so I've got a file called import. Hopefully that's big enough. This is the same sort of thing. It just points at the cleaned up files. And so what we can do, so let's just have a quick look. What do you actually get if you run Neo4j import? So let's run it first of all with nothing. And it'll go, you don't have an into. It's like, all right, fine, I'll put an into temp foo. It's like, there's already a database there. So what we'd actually need to do is actually get rid of that. So I've probably run it before. But what is more interesting, actually, just so you can see sort of how it works. Actually, maybe we'll put it foo bar. So now it's like, you didn't give me anything to import. So let's actually run our import command and have a look at what that does. Okay, so we've got a database already, so let's get rid of that. It's probably me from playing around later before, so let's get rid of that and we'll kick off the import. So you sort of see, so it kind of gives you a little bit of information about what's going on. So we're saying, well, I'm importing the contents of the following files into this directory. So we've got crimes, we've got beats, we've got primary types, we've got locations, and then these are the relationships. You've got 4 gig free that's available to me. I'm going to use 3.56, and you kind of get a sort of a status check as you're going through here, telling you what it's doing. So we've done 4 million nodes, created all those. That took 20 seconds. Then we're doing some node indexes. We're creating dense nodes. A dense node is one that has more than 50 relationships, and there's just a special way that those get stored in Neo4j to optimize the querying on them. We do relationships. You can kind of see it's doing the different parts of relationships, and then we're done. So that took about 46 seconds on this occasion. You get like a little summary. What did you actually import? So we've got 4 million nodes, we've got 12 million relationships, and we've got 29 million properties. So you probably kind of worked out, actually, the last time I ran it, it took 36 seconds. So I was a computer is slightly slower than previously. What I found when doing this sort of work is that it sort of makes sense to get a beefy machine. Well, to some extent of beefy. There are ones available on Amazon if you don't have one one available in your office. So I tried it on one of my colleagues' machines. So he's got a server which has 128 gig of RAM, 6 cores, so it's a bit better than my laptop, and he was able to get it down to 23 seconds. And you'll see that, I mean, we weren't doing a really big graph here because we want to be able to run it during the webinar. So we're working in the millions. This tool is designed for doing things into the hundreds of millions and billions, and as the size goes up, the power of the machine sort of comes into its own. So a sort of recommendation I'd make is when you're doing this sort of initial import, probably do it on a bigger machine than you might actually be using to run your database in production, just so you don't have to wait around so long while it imports the data. Okay, so that's the initial import. So that got in like our initial crimes. But I thought after I'd got those in, I was kind of curious. Is there any way of like building a bit of a mini hierarchy of the types of crimes that are being committed, and could we find anything interesting from doing that? And I came across, I just searched in Chicago crime types and it came up with this website called the Clear Map Crime Summary, and you can sort of see. So down the left-hand side, we've got the crime categories. So these are the top-level categories. So they've got index crime, they've got non-index crime. There's some other ones below that. We'll have a look at the actual page in a sec. And then on the right-hand side column, we've got the subcategories, so kind of what sits below them, and those are what the actual crimes are. That's what their FBI code is actually. So a crime would have an FBI code of 03 if it was a robbery. It would be 04A if it was aggravated assault. It would be 14 if it was vandalism, and so on. So I made it. I found a tool that was able to scrape this, and I created a JSON file just so you could have a look. How do you actually get JSON into Neo4j? So this is what my JSON file looks like. So I've got categories, which is that's a key in my JSON file, and then that contains an array of subcategories. So we've got the index crime one. That was the first one on the list, and then that's got a load of subcategories that you can kind of see here. So we'll have a look at the whole file. So this is the whole thing. So we don't actually have the ability. So if we go through this a bit more slowly, so we've got the index crimes here, we've got the non-index crimes here, we've got the violent crimes here, we've got the property crimes here. They then do actually go into further subcategories, but the dataset unfortunately doesn't actually give you these. So I've only gone down to one level. But what we create is this file here. I'll make it a bit bigger. So we've got the categories. So you see we've got one entry for the index crime. Kind of go down. We've got another one for the non-index crime, and the subcategories there. And then finally we've got the violent crime category as well. Those are not so nice to read. So we need to figure out how we're going to actually get this JSON data into the graph so that we can do some category-based queries. You don't necessarily have to draw this, but this is what I wanted to do. So I thought for my understanding, it would be cool to see, well, what am I actually going to try and do? And this is what we want the graph to look like. So at the moment, we've got what's on the top. We've only got the crimes, and then we've got a lot of stuff around that, but we haven't got that on the diagram. And what we want to do is we want to connect a category in there. So we'll call it the crimes subcategory, and then that's going to have a parent category. Well, in this case, we've actually said that a crime category has a child. You could equally say that a subcategory has a parent. It doesn't really matter. It just depends on what wording you favor. And then another thing that's important is that the way that we're going to connect these two, there'll be two graphs. There'll be this graph, and then there'll be this subgraph up here, which we've already got. The way we're going to connect them together is through this code. So when we import the JSON, which we'll do in a second, we're going to put a code. They've got an FBI code, and then we've got a code on the crime as well. And we'll then do a query which connects them together. So when you're working with JSON, you kind of got, depending on what you're comfortable with, I think there's roughly two ways that you can take on this this problem. So your first one is, okay, well, I know that I'm really comfortable with the Load CSV tool, and I know how to use that, and that seems to work quite well for me. So I'm going to figure out a way to get from JSON to CSV, and I'm going to use the tool that I know. That's perfectly fine. We're going to have a look at how you do that. Or you might say, actually, I'm fine using JSON, and I'm quite comfortable with using one of the Neo4j drivers. So Neo4j has drivers for lots of the different popular languages. We're going to have a look at how to do it with the Python one in a minute, and then I'm actually going to import that through the API rather than using the Load CSV command. And either of these is fine. It just depends what you're comfortable with. Some of you may have come across this. So this is quite a nice tool called JQ. So if you just Google for JQ or jqplay.org, there's quite a nice tool for going, hey, it's like a tool for taking JSON data and generating. You can generate a CSV from it. So if we quickly remember, what does our JSON structure look like? So remember, we've got categories, we've got a name, we've got subcategories. What we want to do is get a row that have category, subcategory code, subcategory description, and so that we can have one row for each category, subcategory, and then the connection between them. And what we can do, so this is what the JQ syntax looks like. So what we're saying is, I want to follow. It makes the assumption you're going to give it a JSON file. So here we go. Here's the categories.json, and then it's going to go down and go, okay, cool. What do you want me to do first? All right, I want you to go into the categories array. So that's what we've got at the top level. Cool. Then I want you to transform that into a JSON object which has a name, and then it has a key name, and then it grabs. So .name is the CSS for sort of going in CSS type syntax. We're going and grabbing the name out of the initial JSON document, and then I want to grab the subcategories array. And then my final transformation is going to be, or next transformation rather, is going to be to actually take that JSON document and then create an array which has a name, the subcategory code, the subcategory description, and then the final step is an @CSV transformation, which then takes that array and spits out a CSV file, which we then direct into categories CSV. So this is what it looks like. So I guess you can hopefully kind of see how we're going to import this. So we've got our categories. This is the top level category all the way down here with index crime. We've got our subcategory code. So those are the codes that we're going to be able to connect to our crimes, and then we've got a description of what was the crime that was actually committed. And this is how we would go about creating this this category and subcategory subgraph. So we're going to use our load CSV again. So we're going to say, hey, I want to load CSV with headers from path to categories. And then I'm going to merge the crime category in and the subcategory in, and then we're going to put a description on as well, and then I'm going to create the child relationship between them, and that will work quite well. Although the eager eyed amongst you will have noticed that I've actually broken one of the cardinal rules here, which was, hey, only do one merge per statement. So if you look at that again, we've actually got 3 merges. So when you're dealing with big data sets, this actually can be quite slow, as Cypher sort of tries to make sure that it's doing keeping the safety properties that it ensures, and doesn't sort of let you get into an infinite loop. But when we're only working with 20 or 30 records, so we can probably choose to break the rule. So it's sort of following along the lines of, hey, know the rules, and then you kind of know when can I actually break them. So here it's fine to break it because there's not very many records. The other approach, if you're comfortable with using one of the drivers, is that you could just take the driver and then process the file and send the file directly to the Neo4j endpoint, and it can then work with that JSON document in Cypher. So we'll go through this a little bit slowly, so you can understand how it works. So this is using the Python Neo driver. So I think this is actually one of the most popular drivers. This is the Python driver for Neo. So even if you're not familiar with Python, hopefully you can still follow along. So at the top we're doing some imports. So we're just saying, hey, I want to get the JSON parser, and then I want to load a couple of things from Python Neo. The first line, I guess, is reasonably self-explanatory. So now you know the password for my local Neo4j, which is Neo. So we're just saying, hey, I want to authenticate on this Neo4j with this username and password. Graph is just a way of saying, hey, I want to get sort of a context which has my graph available. The next line is just loading the categories file so that we've got it available for us. And then you'll notice down here that we pass it to, so this is how you can execute a Cypher query. So what we're saying down the end is I want to execute a Cypher query, and by the way, here's a parameter. And the parameter in this case is that big JSON file that we've got. What we do, once we've got the JSON file, this is the query that we're going to run on it. So we're going to say, all right, I'm going to call this JSON file document. Then I'm going to use the unwind command. So the unwind command can take an array of things and it will give you a bunch of rows. So if we've got like several categories, so if we imagine we did unwind with 3 categories, we now get 3 rows, 1 for each category, and then we're going to do the same for the subcategories. And effectively, this is just going to explode out the JSON document so that we have a really similar setup as we had with our CSV file. It's effectively just exploding things into that same format that we've already seen. And then we're doing the same operations. We're just saying, hey, I want to make sure there's a crime category, a subcategory, and then put a description on and merge that for me. And you remember, this is what we're actually trying to do. We're trying to create this connection between the 2 subgraphs. So one thing I had to do, but I think I've actually done this in the already done this as part of the initial load, is we had to go back and put on the FBI code. Another thing to keep in mind, so always when you're doing these sort of bigger update operations, is make sure you've got indexes on the things that you're trying to match and merge on. Otherwise it will take a lot longer than you expect. And for this one, actually, hang on, where are we at? Yeah, so for this one, because we're going to go over every crime and connect all the categories together, we're probably going to want to do this in batches. So actually, this is probably more interesting to look at in the editor again. So we've got so what we've got here. Oh, actually, hang on a minute. So what we're doing here, so we want to connect. Actually, so we've sort of gone on to the next bit. Actually, I guess. So if we have a look, this is the first one. So what we're saying here, so this is what it would look like, and we can actually probably run that. So if we go back to our command line, so if we go import, so this is all we do. So go import categories, and then it does it. We're not actually printing any outputs. If I go back in here, we can then have a look and see. Okay, cool. We've got some subcategories, so we can open those up. We can expand that out. So these are the subcategories that we've got from our, so we've got index crimes. And you see, it's actually interesting. I didn't realize this until I imported it, but some crimes can actually be categorized as an index crime and a violent crime. So you see some of them have got multiple parents, which is quite interesting. Okay, so once we've got those categories in, so I kind of jumped ahead a little bit. But what we want to do, so now we're actually at the point where we've got those subgraphs. So we've now imported, that was importing this bit. So you've kind of seen we've now got our little hierarchy. So what we want to do is actually go and create this relationship. That was the whole intention of getting this hierarchy in there. And the way we can do that, so first thing we have to do is we have to put in the FBI code on the crime. I think we might already have that, as I mentioned, but if we didn't, we would have to put it on. And then we want to put an index on our subcategory so that it's quick when we're actually executing it. And another thing to keep in mind, remember that we've got 4.1 million crimes that we're trying to import. So we probably don't want to do those all in one go. We probably want to batch those up a bit so that we can so that the transaction state is not too big. And the way that we can do that is by making use of the combination of the skip and limit operators. So what we're saying here is I want to find, well, we're saying find all the crimes, but then we're saying actually, and so the crimes will come back in the same order. So we want to go, hey, I want to skip a certain number, so that will start at 0, and we're going to limit it. Let's say we pick a number 10,000, and then we want to do this connection of the subcategories and the crimes together. So we're doing a match to find the crime, a match to find the subcategory, and then a merge to connect them together. So before we do that, let's quickly let's get our index on there. Actually, if you probably remember, we haven't actually put any indexes on here yet. Oh no, we've got a few. So we haven't actually connected the full graph in here. But what we would actually want to do if we wanted to connect the one that we imported using the import tool, maybe we'll do that. Maybe we'll do that quickly now. Is in your Neo4j server properties. By default, it points at data graph DB. What we probably want to do is stick that at our. We're going to put that at data crimes DB, and we're going to quickly just copy across the database that we created. So let's just quickly do that. Forgot that step. So we'll get that in there. So we'll just copy the file across. So what you can see here is that actually the file that gets created that we created with the import tool is actually a database. So we can put that in there. Let's quickly do that. I'll give it a few seconds. So I think the size of this file is probably about 1.5 gig or so. And so once we get that there, then we can quickly restart. I've got the indexes that we actually need to create are all sort of sitting in this file as well, so we can run that afterwards. So let's just quickly restart. So Neo4j bin Neo4j restart. So just give it a few seconds. So now it's going to be using our new database because we updated it in here. Okay, so we're ready again. So let's just quickly refresh that. And if we did, let's just check. Oh. We'll do a quick cat. This might take a few seconds. We could do it with. So this is actually going to sort of goes across all the crimes and check how many there are. So we've got, there we go. So we've now got 4 million, which would mean if we do. So if we then let's import the categories again. So we've got the categories in there. Always got to remember, don't forget to put your indexes on. So let's get those on. So if we do. So actually, if you have a look, so if you don't have any indexes, that's sort of what it looks like. And if you then let's try and do one of our exploratory queries. Say we try and find this crime. It's going to take a while because it's going to look across every single crime of the 4 million until it finds it. So what we actually want to do instead of that is get some indexes going on. So you can only handle this for so long before you end up killing it. So I'm not sure how long it's actually going to take. Hopefully it won't take too long. So there we go. So it takes a while, but there's our crime. So what you actually want to do is get some indexes in there. So you'll notice that the indexes return and actually get created asynchronously. And if you look at the schema, you see these ones. There wasn't very many nodes, so they're ready to go. But the crime one's still populating because it's got a few million to work with. And so when you're in the state of populating, you can still query, but it's not going to use the index. So if we give it a few seconds, that will eventually come online. And so that's going to create our subcategory one for us as well. And then we could then run. So we've actually got a script that does this batching for us. So let's have a quick look at that. We're not going to run this one. This takes a bit longer because it's working all transactionally, but it's very similar to what we had before. So we don't actually need that bit. So you'll notice all this bit's the same. So we authenticate, and then we've got our query in here. So I've got a few versions of this query actually. I'll show you the one that works the fastest, and then this is the bit that's interesting. So we're saying I want to start skipping 0 rows, then I'm going to go up to, I'm going to do 10,000 at a time, and I just got a loop, so it's just a while true. Go through, execute the query, so this is the query, and this is just for counting how long does it actually take. And then at the end, if the number that you processed, so you notice that we say, how many did you actually process? If it's 0, cool, we're done. We've connected all the graph together. If we're not, increase the skip by 10,000, and then we'll do the next 10,000. So we're kind of just going on a window along the graph. Okay, let's see. I wonder if this is actually done now. Let's have a look. Great. So it's now there, and if we do our, let's have a look at our crime. Boom. So now it's much quicker. Obviously, it's almost instantaneous. There's a prefix that you can put on these queries called profile, which will show you what's going on. We're not going to go into that, but you can sort of read about that in the Neo4j documentation. One thing I found while doing this batch connection of the crimes to the categories is that the merge was actually starting at what we call a supernode. So a supernode is a node which has lots of relationships going out from it or coming into it. So in this case, you probably would have realized the subcategory actually has a lot of connections. So since there's only 20 subcategories or 30 subcategories and 4 million nodes, well, they've got to fit in somehow. So you'll see some categories which have 100,000 nodes going into them. Some actually have 500 or 600,000. And at the moment, it seems like the merge actually starts the wrong way around. So it starts at the expensive side and goes through all those relationships, trying to see whether there's an existing connection to the crime. There's another command called create unique, and that seems to work the other way around. Although I probably would try both of them because it seems to be, I'm not sure it necessarily always holds, but something to keep in mind when you're doing that type of thing. And then, we've kind of looked at this already, this is the script. So to wrap up, I wanted to show one last thing. So we've had a look at doing initial data. We've shown how to scrape or how to get a different data source and connect that in. What we haven't actually had a look at is, well, what do we do if new crimes come in? So in this case, the new crimes coming in was me downloading the Chicago crimes dataset again a year later and realizing, oh, there's a load of more crimes and I don't really want to start from scratch. I'd quite like to just import the diff. So what I did, so I wrote a little script that went through the two files and found it was quite easy. They actually have, you can kind of see here, they've got a date column, and so you can just go, oh well, actually I'll just get everything that's more recent than a particular date, and that's my new crimes that have been committed. And then I've made like a little program that just simulates new crimes coming in. And what you get is quite similar to the JSON document or to the CSV file that we had, but we're just treating it as a map. So we've got an updated on, we've got a district, an arrest, a location, and so on. It's exactly the same data, but we're going to feed it into Neo4j's transaction endpoint, and again we're going to use the Python Neo driver to do this, but this time we're going to actually do lots of statements at the same time. So the transaction endpoint allows you to batch lots of queries together. So for example, we could send, in this case, I've actually got an example where we're sending them in chunks of 100. You can obviously do them individually if you want, but sometimes you might find that actually batching up a bunch of things is more efficient. So in this case, I'm just doing them in batches of 100. It's just an arbitrary number. So all we're doing is saying so we're processing. There's a crimes. There's a list of crimes. It's not that interesting how it's generated. We're just saying I'm going to group those by hundreds. So I'm going to have 100 crimes at a time. I'm going to create my transaction here, and then I'm going to go through the chunk. I'm going to append and then send across. So you can sort of send across the Cypher queries. So those are up here, and they'll start running when you send them. And then once we're happy that we've got our batch, we've done enough for this batch. So in this case, once we've done 100, we're going to then send the commit command. And obviously, it's an all or nothing thing. So if one of them fails, then effectively, conceptually everything rolls back. And you'll know, I mean, we can have a quick look at the query. So again, params is the parameter that comes in. So that's this one here. This is the Neo4j syntax for referring to a parameter. So what we're saying is I want to merge the crime, so make sure this new crime exists. If it's the first time you've seen it, which it should be, set these properties on it. I'm then going to pass, so width is pass through the crime, because I then want to go and match, connect it to a location. And the location is already going to be there. There aren't any more new locations. And the same thing with the beats. There aren't any beats. And so what's quite nice about this way of updating is that we're able to do everything all in one atomic operation. So we're going to create the crime, connect the crime to the location, and connect the crime to the beat. And obviously we could then do other things as well if we wanted to. But to save space on this slide, I've just done a few. We can have a quick, to sort of wrap up, we can have a quick look. What is that? What would that actually look like? So it's reasonably similar to what we've got before. This is all on GitHub, so you can have a look at this bit later. And here we're creating an iterator of the crimes. Here's the query, and this is sort of what do we actually want to execute for each transaction that we get in, and here's our batching, and then we're just printing commit so we can see what's going on. And that's basically it. I guess I've taken almost 57 minutes. So if you want to grab the code or play around with this, I think the instructions on the README are all right, but if you have any problems following them, obviously give us a shout. But this is where it sits, and if you don't have a pen to write that down, Greta will send it out, so you can always have a look.